Hello everyone, and welcome back to COSS, our course on commercial open source software startups and how to spin them off from university. My name is Dirk Riele and I lead this course. So today we are starting the middle part of the lectures on this topic. In the first part we discussed the software industry in general, and now we will be discussing open source software communities, and commercial open source startups and strategies. Today it is open source software, the first of these 4 lectures of the middle part, and I will be talking mostly about software as open source software as an artifact, meaning something you build. And then next lecture will be about the project communities behind these artifacts. It will be a lot of information. I have a course on open source software of 15 total lectures, and I'm squeezing much of it into this 1 hour, so bear with me. What is open source software? Well, open source software has a predecessor called free software, defined in the 80s and 90s of the last century, and then open source software as a term for something that's basically the same in the late 90s. Free software is simply software where the user gets certain rights, and these rights are defined. The user must be allowed to use, study, modify, and distribute the software, even in changed form, free of charge, and any other restrictions. Open source software, which was a reaction to a lot of philosophy that didn't make sense to many of the very pragmatic software developers developing free software and then open source software. Open source software was coined in reaction to that, but basically means the same. Open source software, by way of the open source software definition, is software which fulfills 10 criteria, but when those are being distilled down, it's exactly the same. If a user has the right to use a piece of software, to modify it, and to distribute that software, distribute it in a modified form even, all of that free of charge and other restrictions, then the software is open source software. More pragmatically, open source software is considered open source only if it has a license which spells out exactly these rights, but also some obligations that are given to the users, the recipient, the licensee. And then some piece of software becomes open source software if it has such an open source license as defined and accepted by the Open Source Software Initiative. Free software and open source software for all practical purposes are the same. The host or definer of free software is the Free Software Foundation, and of open source software is the Open Source Initiative. And we often just merge these terms and talk about FOSS, or free and open source software, though I in general just talk about open source as the general term. And we know open source software. There's a lot of it, and there's a lot of good software that is open source software. And as an end user, you may have seen many of it already. There's no domain really where open source software is not present, whether it's video editing software like Blender, or technical software like the Apache web server, or office software like the OpenOffice or LibreOffice suite of office tools, word processors, and so forth. Or whether it's enterprise software like Sugar CRM or Jaspersoft. Open source is everywhere for every domain and conceivable use. Open source software is being developed. And that makes it an important force to reckon with, because if there is high quality, free to use software available, then potential competitors, non-open source competitors, usually have to fight hard to survive. So let's take a look at the history of open source. In the beginning, when software was being coined and recognized as an independent artifact separate from hardware, there was little recognition initially of software itself, but certainly not of open source software. The concept of open or free software at the later time wasn't even recognized as such. However, people were often freely sharing source code because so little value was commercial value was attached to it. In the 80s, that changed because companies recognizing the commercial value of software were closing it down, upsetting in particular a person called Richard Stallman, who decided to fight this trend of closing software by inventing free software, the idea of free software and the idea of licenses to ensure software, in his words, would remain free. The outcome of this work is the family of open source or free software licenses called the GNU licenses. In the 90s, in reaction partly to Stallman being philosophical, even aggressive about proposing and marketing and evangelizing the idea of free software, the open source initiative came into being by pragmatists who realized the value of free software but didn't want any of the philosophy or brouhaha around the, in particular, GNU family of licenses. An important innovation in the GNU family of licenses was, as we will discuss, the copyleft effect, or a clause in the license that would require anyone who passes on such licensed code to lay it open as well under that license, even any additions or changes they may have made. And that may have been to Stallman's taste. It was not to the taste of the pragmatists of the 90s who coined a new term, open source, to compete with free software and came up with their own definition of open source and the licenses that would match that definition, usually without that copyleft clause to be discussed in a bit. In the early 2000s, professionalization of open source set in. Companies came into being who realized not only the commercial value that was already present in the 90s, but who templatized or canned, defined repeatable ways of how to commercialize and commercially benefit from open source. And today, open source in the 2010s and onward, open source is just mainstream, if you will, present in every piece of software usually, and all around available and part of the tool chest, strategic tool chest of any software vendor. From a commercial perspective, open source has very much become, as I call it, an on-ramp to the cloud, to cloud services. So then we need to distinguish different types of open source to understand how this is a rich set of phenomena under one label. The original open source was a volunteer open source. That was GNU Emacs by Stallman, a text editor, and Linux by Linus Torvalds, but always then with many contributors. These projects were held together by strong people on the one hand, and just a license that was put on the original code, and that new developers put their own contributions under as well. As a consequence, traditional open source software like the Linux kernel is communally owned, arguably, because a large number of people who contributed over time hold copyright in parts of the source code of that kernel, meaning their own contributions. And It's important to understand that this is the artifact with shared ownership, around which there is a project community, meaning people who drive the project, the software forward. And without people, software is dead. So today again we will look at the artifact, the software. That's challenging enough. But next time we will look at the project communities around said software, around said artifact. Here is my view of the history of open source, and I like to split things into bands, meaning categories and how they evolved over time. Traditional community open source projects were there first: GNU Emacs, the GCC, the GNU compiler, then the Linux kernel, and so forth. The first commercial company to commercialize something about open source were service and support firms. I think Cygnus Solutions, which serviced the GCC for customers, is noteworthy here. So they made money by providing services and supporting important open source software like the GNU compiler. The next type of software firm built on open source are the open source distributors, companies who make a large amount of open source software, here usually the Linux kernel and the tools around it, who make these different thousands of pieces and components work together well so that customers of said distributor then feel comfortable using this product in operations. So SUSE in 1992 and Red Hat in 1994 were the original Linux distributors, but there are niche players like the German Univention Linux provider, Linux distributor, focusing on the public governmental space. Distributors and support firms for commercial then came in 1999 with the Apache Software Foundations, non-profits, notably developer-led foundations, where companies and individuals who wanted to develop software came together under one roof to have rules they all abide by. The original traditional projects could suffer from strife, and then there was no way of solving problems. By creating non-profit organizations like the foundations, you would get bylaws, you would get problem resolution processes, all of that. And if some software became so important that it was important for the companies usually involved, then they would want such a space for resolution. More on that later. In 1995, maybe MySQL, but also at the same time other what I call single vendor open source firms came into being. These were companies who developed open source themselves, so it was not a community, but who then went to market and sold subscriptions to updates and so forth from it. And this is what this course is based upon, so we will dive into these single vendor open source firms in more detail in full lectures later on. Finally, there's a new phenomenon around the block called user-led consortia. These are the users of software, user companies of software, who join forces to create an ecosystem of providers of software to them, so they manage the development of open source software and then create that ecosystem of vendors and consulting firms around that open source software for according to their liking. And open source, because of these separate phenomena or coarse patterns of how legal entities like non-profits or companies organize, has become sustainable. If it wasn't for these models, open source might not be sustainable. The non-profit organizations are community-led ones like Mozilla, vendor-led ones like the Linux Foundation, and user-led ones like the Kuali Foundation for university software. The for-profit models are single-vendor open source firms where one company dominates or outright owns a piece of open source software. The distributor firms where the value to customers is in that distributor making sure tens of thousands, sometimes components work together well as finally service and support firms which service well-known, important, but communally owned open source software. So I already said that open source software in the narrow sense is software becomes open source software if it's put or made available under an open source license. And if you go to the website of the Open Source Initiative, you'll find these 10 requirements of what a license needs to fulfill to be considered an open source license. Could then go through an approval process at the Open Source Initiative to be listed on their website as such. Here, we want to take a closer look at what the constituent parts of an open source license are, so that we better understand those, understand the effects it has on intellectual property, and ultimately how to build a business around this using a tool like a license. Open source licenses are in the right hands a tool, a sharp tool, a useful tool. They are not a philosophy. They only become a philosophy if people try to make it one. Here we will see how open source licenses are a tool for communities as much as for firms. So any open source license has these different parts. It usually contains a copyright notice where it says who is that creator who is licensing out this work. Then the license spells out the rights the creator gives the recipient, so what the licensor provides to the licensee, and these are the usual ones: permission to use for free, to modify, so to receive in source form, to modify, and to distribute on, even in modified form. Then there are the obligations to fulfill by the licensee, the recipient of the rights grant, if they want to actually have that rights grant become valid. So that is often overlooked. You may have, as a recipient of open source software, to fulfill certain obligations before you can, pass on said open source software as part of products. Usually, if you're only using open source software in the quietness of your home or in the data center of a company, but you're not distributing it on, there are no obligations to fulfill. But if you are a vendor and you are including open source software in your products, and who isn't, then you have to fulfill the obligations spelled out by the license. Then there are the prohibitions, things you are simply not allowed to do. Usually that's just claiming endorsement by the creator of the original license text, which is a legal text, has a creator itself. So if you use the MIT license, you are not allowed to say that MIT endorses your software. And finally, all licenses usually say that you're not given any warranties or guarantees about the functioning of the software. After all, it's free, so nobody wants to stand up for the software. And some licenses are very complex, but they can also be simple. Here's an example. This is the MIT license. It has, of the 4 components that I just explained, it has 4. Of the 5 components, it has 4. It does not include a prohibition, but it does have the copyright statement, it does have the permission notice, meaning the rights grant. Then it has number 3 here, the obligations to fulfill if you pass on this licensed software to yet another party. And number 5, it has the disclaimer. This is a legal text created by a lawyer, probably for the MIT, or obviously for MIT, the university. And as such, it's free to use. So the lawyer or MIT said you can freely use this license, so you're allowed to use this license and apply it to your source code. It is actually a template because you have to modify it to become a real license, in this case to fill in the copyright statement. Believe it or not, many people never bother to put down the year and their name as they license out some code. And so you have to infer who the copyright holder is. So from an artifact perspective, the challenge is in the obligations. Everyone likes the rights grant. Usually you have no problems with the prohibitions because you're not going to claim that MIT loves you unless you have good reason to. And the disclaimer is also kind of obvious that if it's free, you can't expect any guarantees. The challenge is, again, in the obligations. Some of these obligations are seemingly simple. In the MIT license, the obligations were that you must include in all copies of the so licensed code this permission notice, the license. And that includes the copyright line, so that's called attribution. If you're using MIT licensed code or Apache software version 2 licensed code or any of these licenses, so-called permissive licenses, you usually have to include the copyright statement and or the full license text, including the disclaimers. Sometimes that's all neatly packaged in one piece of text. Sometimes it's spread around the source code and you've got to hunt and peck for it. And these provision of this textual information to your own recipients is usually put into the legal notices. So you need to have in your mind a two-step. You are the recipient right now of open source code from someone else, and you're passing it on to a third party. You, in the middle, passing on to a third party, have to fulfill the obligations of the original creator, including creating these legal notices, including attribution, license text, disclaimers, and so forth. And there's a lot of variation in these obligations. There is one specific obligation that for the longest time has held open source back, because foes of open source argued that it's trying to destroy commerce, and that is the copyleft clause. So licensees who have a copyleft clause are called copyleft licensees because that clause is so important. The copyleft clause is also known, not so fairly, but it is also known as a viral clause or a viral license. And what it means is that you as an intermediary who takes code licensed to you under a copyleft license, works on it, changes it, enhances it, and passes it on to a third party, that you are only allowed to do so, you only have the rights to use the original copyleft license code if you pass on your modifications under that same license, meaning you cannot put a commercial license onto your modifications or the whole work. So here you can see an illustration of how this plays out. There's a P programmer, an original open source developer, who licenses out his or her work under an open source license. You, V, are the vendor who uses the component or the open source code as part of a commercial product. So that open source code is just part of your work. You do your own work too, and maybe even put together many different open source components. And then you sell it on under a commercial license, or that's what you want to do, to a customer or a client, and so you need to have the rights to do that. The provision of the open source component from P to V, from the programmer to you, the vendor, is called the original distribution, and as you pass on as part of your product the open source code, you are redistributing it. And that's, or just distributing it. Now, if the license of the original code is a so-called permissive license, then you can mix and match your own code with it and put a commercial proprietary license on it. And hence, while you have to fulfill the obligations of the MIT license, so attribution, so provision of attribution, license text, and so forth, disclaimer, you can still sell the combined work under your commercial license. You just have to provide in your legal notices things that fulfill the MIT license obligations. If, however, the license of the original programmer is a copyleft license, then the copyleft clause requires that you can only legally, validly pass on your own modifications or a derived work if it is under the same license like that code that you received. So that's why they call it a viral license. The original license keeps propagating. And because vendors don't like that, they want to sell a product under their own commercial license for which customers have to pay. Vendors avoid copyleft licensed code almost entirely. Not always. There are business models where it can work, but in general, most vendors will simply say it's not acceptable to use copyleft licensed code in their products. And that was a real challenge for the longest time, because the GNU public license, in its version 2 at least, was long the dominant license by developers of open source software. Probably because it was the earliest license. It was the first choice, and then the Linux kernel chose it, and hence people thought, what can go wrong if I use that license? Over time that has changed though, and the GPL version 2 still has a high market share, but it's increasingly the old software, and newer software, new open source software projects are permissively licensed, in particular under the very simple or comparatively simple MIT license. And you can see number 2 and 3 on the right side, the Apache license as well, are both permissive licenses that don't require you to lay open your own modifications to the source code if you put some open source components into your commercial product. This is a deep topic. I will not go too much into it, but there are 50 to 80 licenses or original open source license templates. There are 5,000 variations that are commercially relevant of these license templates because people fiddled with the text, all of which you need to understand as you possibly use open source code in your products. Here you can see how some licenses interact or are compatible with each other or are incompatible. The most well-known incompatibility is between the popular Apache 2.0 and GPL version 2 or later licenses. I will leave that to dedicated courses because it's a tricky and detail-rich topic to be discussed separately. So then, no company and certainly no startup these days in the software space, no software startup can really not use open source software. It would be crazy to build everything from scratch or purchase licenses from closed source vendors to build your product. All open source startups, commercial startups, whether open source or not, will usually build on an open source technology stack. You look at the average website out there, it's 95% open source and then a thin layer or veneer of commercial code on top of it. So open source makes startups happen, has significantly reduced the barriers to creating a software startup. And that's good, but it also comes with problems. The problems are to be compliant and to be compliant with the obligations of all the open source code that you're using. So from the discussion we just had about license obligations, you may think that the problem is in avoiding copyleft licensed code. That is a problem, but it's actually not the main problem. You can avoid copyleft licensed code by educating your developers that they should not use so licensed code, which includes a lot of things, for example, not copying from Stack Overflow. And you can teach people that, and then hopefully they will comply with that, and you will keep your product copyleft licensed free. The problem is actually a different one, which is the large complexity of open source software that you're including because of the dependency graph. So here you can see it illustrated. You have a product that's your code, which sits on top a large amount of open source code. So you directly include valuable quality open source components for a UI library or for a database, what have you. And so you know what you're doing. So that's tier 1 here. You may also license a closed source component from someone, maybe because there's no open source component available that does the job for you. And you also know about that closed source component. You have to dig in, though, to learn what those open source components and closed source components actually depend on themselves. So the dependencies are not just your first layer of the dependencies your code declares in its build files. No, the dependencies are a whole graph going into much depth, including more and more and more components. It's literally, or not so literally, it's metaphorically, analogically, I think it's an analogy, the iceberg with a big part under the waterline. Your product has its component, you include components which have subcomponents and reference other components, and it quickly gets out of hands in that you have hundreds, if not thousands, of other open source components by different people that become included in your product that you sell to customers. Why is that a problem? Well, you have to comply with the license of every piece of open source code that you're using. And you therefore have to identify this full graph, know every single component, and for every single component understand the license and sometimes multiple licenses that the component is coming with. And interestingly enough, the annoying part and the hard work is, again, nothing about copyleft. It is often the attribution clause. Attribution, if you may remember, is that copyright statement. So for every copyright statement in that whole component dependency graph, you have to find it. And you have to put it into your legal notices next to all the license texts. And if you want to know how much work that is, because these copyright statements may hide anywhere in the code you're using. And you may not even be using source code, you may not even be building from scratch, you may be including binaries, so then you have to look at the source code behind those binaries that you download from the web and look at the source code and identify the copyright statements. If you want to get a feeling for how much work that is, open up your Android mobile phone and go to third-party licenses under System. There you will find the legal notices for third parties, which includes open source software. From a vendor perspective, an open source component is and indeed should be treated as a third party. And Google here does it pretty well. You get a list or an index into all the different components that have been included in Android. And for each component, there are the license obligations being fulfilled as far as this is possible to express as legal notices, meaning the copyright statement, the license text, and so forth. Scroll through that list. You will not finish scrolling quickly. It's a long list. And compiling that list is a must if you want to be legally compliant with all the open source code you're using, and can take a lot of time, therefore. And it's easy to overlook something. Now, how is that a problem? Well, it's a problem if you want to be legally correct, but maybe you'll say, whatever, no student, so nobody is suing me, doesn't matter. Well, there are people out there who are suing you, and then it becomes a business risk decision. So you should obviously comply with all the licensees. If you make a mistake, what's the risk of discovery by someone who might sue you for it? Well, it's higher in the consumer space than in the enterprise space, because consumers might be more open source enthusiasts. Low price has a higher risk than high price, because you need to get your hands on the software, or say a device which includes the software, which then should have the legal notices. If it's embedded, it's more easily accessible to people rather than if it's in the cloud and just a service over the web. And of course, a copyleft license has those extra challenges, because people who license out under a copyleft license are often more interested in enforcing their rights than other people. So you have to look at your specific situation and assess the risk of discovery of any license violation, and then you can decide how to go about it. Better yet then, though, than fixing problems after the fact is to make sure they don't occur in the first place. So if you're a software vendor, these days you should have a so-called open source program office, or someone who is responsible for managing open source in your products. And that's the so-called domain of open source governance. Governance is the set of processes and practices, etc., that you use to manage a social system, and then open source governance in companies is that set of processes for the purposes of selecting components for use in products, managing the introduced dependency on that open source component, and so forth. I provide 2 examples of documents that spell out governance rules. The University of California has one such document. It's heavily focused on patents, though, and so I think I'm providing it here because it's interesting. But my own research group's governance rules are a bit more pragmatic, if you will, looking at it from an engineer's perspective. So I provide my own governance rules. Here's a quick summary. First of all, if you don't know the license of some code, don't use it. Just because there's code on GitHub doesn't mean it's free to use. In fact, if there's no license for that code on GitHub, then it's proprietary code. You do not have any usage rights. The exclusion rights of the copyright holder kick in. Do not copy source code that's copyleft licensed is a common governance rule in most companies, because nobody wants that copyleft license in their code, because they don't want their own product to lose the licensing flexibility for their own product. And for that you need to understand where copyleft license code comes from. That would obviously be GPL version 2 license code, but Stack Overflow, for example, if there's code on Stack Overflow, most people ignore that, but code on Stack Overflow is copyleft licensed. So you can't actually use that in your product, or if you do, you have to comply with pretty cumbersome Creative Commons share-alike license, I think. Do not copy and paste and lose lineage, etc., etc. What you should do is usually use permissively licensed components. So the rules an open source program office should give its developers is that you basically have your allow list separately from your deny list, and then some sort of must ask list where it's not clear whether it's allowed right away. Usually companies are restrictive, so if it's Apache licensed and from the Apache website, then it's okay. But if it's Apache licensed and from GitHub, it may not be okay, because you just don't know what people do on GitHub. Just because it says Apache on the outside doesn't mean it's got Apache on the inside. So nobody ensures that on GitHub. So GitHub in general is a problem unless the repository is governed and managed by a company that knows what it's doing. So here's an overview of how it could look like. This is straightforward from my own research groups. Governance rules distinguish, so name specific projects if they are common, put them into a local repository. You can allow list certain licensees and some sources, but also clearly identify which sources are not okay. So now that you're using open source in your products for good reasons, because it's high quality software for free, no vendor lock-in, you can modify as needed and fix the problems yourself you might encounter. Question is, are there any downsides to using open source software? And sure enough, there are. So one we discussed, you need to be very clean about the intellectual property rules. Make sure you comply with the license. Also, you need to watch out for any security vulnerability introduced by an open source component. You may think, well, if it's a third party closed source software, there might be security problems too. Well, the challenge with open source, on top of that there simply might be problems, is that, well, these vulnerabilities become publicly known, and if someone can find out that you are using these components, you can possibly use it against you. And why might they find out that you are using said component? Well, if you are complying with the license, it says so straight in the legal notices that you're using this component. Finally, if you're depending on an open source component, then you have a technical dependency. So you need to make sure that the open source project supporting the software doesn't suddenly take a left turn or a right turn, and the software changes in such a way that it becomes unusable to you. These are fundamental problems. If you are building a business on top of it, you also need to make sure that you actually can keep access to the source code, that nobody can suddenly pull away trademarks if you rely on them, and nobody has any patent rights in the software that are unknown to you and that you might not agree to or might not get a patent license to. So you need processes for all of this. The Eclipse Foundation has a nice governance process, and you need to ensure that your own intellectual property as it builds on the open source software remains clean, and I just discussed this under the open source governance processes. Security vulnerabilities are quite prevalent, quite strong. Here's a screenshot from a website provided by Sonatype, provider of Maven Central, where lots of code gets downloaded all the time because people download binaries, and they sometimes download old versions of binaries with known vulnerabilities. So Sonatype can measure by looking at the downloads how often faulty or vulnerable components are downloaded. It's 1 in 8 here. 1 in 8 open source component downloads contain a known security vulnerability. So this is quite real. And then if you choose the wrong project, and for example, someone has commercial intentions with it and may try to lock you in and may try to upsell you, then you might be in trouble. Here are a couple of examples of where this happened and actually went wrong for the original vendor. So Twiki is an open source wiki, and when they tried to commercialize it, it so upset the community that it forked to FOSSWiki. Same thing happened with Nagios, a data center monitoring tool. When they became so slow to react to change requests, Iceberg was forked from Nagios and has been redeveloped from the ground up now. It's a Nuremberg-based commercial open source startup, Iceberg, and so that is another example. And finally, another Nuremberg example is the Nextcloud fork of OwnCloud, when there was disagreement between people working on OwnCloud. They spun off Nextcloud, and both are competing in the marketplace now. With that, I want to take a look at how open source software is useful to you as you're including it in your products, but also as how you might make your product available as open source. You can maintain control using well-known control and steering mechanisms. So you need to realize that at this stage, there are really two perspectives here. One is the perspective of any vendor using open source components in its products. So that can be a commercial open source startup or an established vendor like SAP. Or if you're a commercial open source startup specifically, and you make your product available, your own intellectual property available under an open source license, and you have commercial intentions, you may want to define what people can do with it and possibly restrict that. And for that, you need control mechanisms. Now, if you who is listening is an open source enthusiast, you may already have an allergic reaction, because to many who emphasize the openness value and the community value in open source, the idea of someone might want to control it is very foreign or an anathema. We will look at project communities in the next lecture. Here, whether you like it or not, I will simply look at mechanisms that may or may not be useful to you from a business perspective. And of course, it's up to everyone, arguably, to use this poison cabinet or kitchen cabinet of potential poisons or not. Whenever you use such a control mechanism, the consequences could be that people notice and are upset about it. So arguably, choose wisely. So with that, the control points and steering mechanisms in open source that I'm aware of are these 6. 4 of them arguably are hard, legal, based in the legal systems, intellectual property control mechanisms. And 2 are social leadership mechanisms by which you can exert influence and steer, arguably, so not so much control, but steer people according to your interests. When talking about control using intellectual property rights, all the relevant intellectual property rights come into play. If you own the code outright, and as we will see, as a commercial open source software startup, you usually should own your code. You have the copyright to your code. And of course, you could argue then that you may change the license in ways that favor you, but not those who you are trying to wrestle or who you're wrestling for control with. If you own the trademarks behind some open source software project, you can threaten to, you usually make available usage rights to the trademark, but you can also threaten to withdraw it. This may sound, so a recent example is Google and the Open Usage Commons, who for a popular open source software project never really provided the trademark rights to the community. So other companies very much were worried that they would build on Istio, that's the project's name, and Google would suddenly tell them that they can't use that term any longer because it's trademarked by Google. So that pressure on Google mounted, and to get some of that pressure away from them, they created the Open Usage Commons, a non-profit organization into which they gave the trademarks for Istio, but also for Angular, I think, and a third component, trying to soothe the anger or the fears by other companies that Google might withdraw their marketing or kill their marketing ability by withdrawing the right to use the trademark. So Open Usage Commons, all it does is manage the trademark right. And it's staffed with Google people, basically. So in the eyes of some, Google really just sidestepped the problem and didn't solve it for them. Patent ownership is another one. If there are patents in the code and you don't license out the patent by way of an open source license with a patent clause, you can threaten to charge patent license fees, and that might keep people in line. You may own the relevant properties, domains, websites, social media channels, Twitter accounts, all of that, and dominate discussion and steer it in a direction that is to your liking. All of these things are things to secure if you want to exert such control before you let someone else get a hold of it. Then there is social leadership. If you are, for example, a core team member, you have high visibility to the project community, and you might create strife. You might even split the community, diminishing its total power. And certainly if you are arguing against the inclusion of certain people, and you can do that by being a committer who does not accept other people becoming committers, meaning core contributors with access rights, change rights to the code repositories. This way you can keep people out. Specifically, committer rights are important or valuable because you can just keep code contributions out of the main line of a project because, well, you're just not accepting them. In open source, as people contribute to an open source project, it's a two-step process. They make a submission. They can't just change the code repository. That submission gets reviewed by a committer, and if that committer does not accept the contribution but rejects it or just never says anything, which effectively is a rejection, then that code contribution doesn't make it into the main line of the product or the project. And hence, if to you it's important that that particular compatibility with some hardware or so is in the project, but it never gets there because it's a competitor of yours who's keeping your contributions out, well, then you're annoyed and you might go away, and the owner of that control point, the company which employs the committers, one a small better. Committers also lead the technical direction, so they muster and direct development forces. All of this is highly annoying to true open source people if you were to do this, because you're obviously not necessarily acting in the interest of the open source project, but in the interest of a commercial vendor behind the open source project. But that's exactly what we will be talking about in a couple of lectures, because that's how you build a business. If you use any such control or steering mechanisms, use them sparingly, use them wisely, or you will lose the trust of your community, which from a commercial perspective again is a valuable asset that you should not lose. So with that, in today's session, I've gave a short overview of what open source is, the definition and its history. We looked at licenses, very high level, and again, that warrants a deeper analysis and discussion at some other point of time. But then we also looked at how companies or vendors make sure that their products are license compliant. And we looked at problems with using open source and products, or ways of how vendors or companies who own open source possibly also control it. And that might be you if you're such a vendor, or this is something you need to know about if you're using somebody else's open source code. Because if you use other people's commercial open source and they eventually try to turn you into a paying customer at a point of time where you don't want that or don't have that money, then maybe you should not have chosen that open source in the first place. So with that, thank you very much for your time and attention today, and we will continue next time with a look at open source software project communities.